Hi everyone, and welcome to lesson 6 of computer systems. So in this lesson what we're going to look at is high level language translation, and you'll see that I've scored out the last 3 topics there in computer structure. So lesson 5 we were looking at the 3 parts of the processor, and we've also covered memory locations in that task sheet, and finally the data and address buses. So this is us onto the last piece of work in the computer structure element of computer systems. So high-level language translation is what we're going to look at in lesson 6. So when we're in school, we write our program code in what is known as Visual Basic. So Visual Basic is the language that we use, and the program that we write that code on is called Visual Studio. So Visual Basic, the language, is a high-level language, and it uses English type words and phrases which make sense to us. So when we're programming from scratch, we're actually writing some words that just appear like normal English words, but they're actually program code. Okay, we'll obviously have a chance to look into that and to play about with it when we get back into school, but you don't really need to know the ins and outs of it for this task. We just need to know that Visual Basic is a high-level language, okay, and that it uses English type words and phrases which make sense to us. So it makes it really quite straightforward for us to program any software applications that we want. High-level languages are portable and can be used on different computers. Okay, so Visual Basic is a portable program or a portable language that we can use maybe on my laptop, on the school laptop, or the one that you're using currently. Okay, so the program that we write at school will also run on your laptop at home if we use a high-level language such as Visual Basic. Machine code is the only language that the processor understands, okay, and it's represented by a series of ones and zeros, so we know that that's binary. Okay, so machine code is just ones and zeros, it's binary. It's really difficult to learn and understand, and then obviously it would make it quite hard for us to edit it, because we don't really know what the ones and zeros mean when we're talking about thousands and thousands of lines of binary. Machine code will only run on the processor for which it was written. Okay, so it's not portable. So that means if I create a program from scratch on my laptop at home and I write it in machine code that my processor of my computer understands, I won't be able to then see that program or run it on a computer in school, okay, because machine code is only understood by your personal processor in the computer that you've written the program on. We choose to write our programs in high-level languages because it's much easier for us, really, but they must be translated, okay, before the processor can do anything with them. So it's all well and good writing your software application, but it's not going to be usable until we translate it, and that's what I'm going to talk about just now. So there's 2 different ways of translating high-level program code into machine code instructions. Okay, so what we're doing is taking that plain English code that we've just written and trying to convert that into binary, okay, so for our processor to understand it. And the way we do that is translating it using either an interpreter or a compiler. So if we have a look at the interpreter, an interpreter program translates and executes the original high-level language program line by line every time the program is run. Okay, so picture you have just written a program using Visual Basic. Okay, you've just written maybe a couple of lines of code that is one program. If you're using an interpreter to translate that into machine code, the interpreter will read line by line everything you've written and translate it. That obviously means that it's a longer process, and the original program and the interpreter need to be in memory every time the program is run. Okay, so it needs to be stored in the computer every single time you load up that application and try and run the program that you've written. That makes it really inefficient. The only good thing about it though is that interpreter programs, if there's any errors that need to be reported, they appear straight away because the program is running line by line to translate it. As soon as it comes across an error or a mistake in the code, the program will stop and identify the error and let you know what the error is. Okay, so that's really just to benefit novice programmers. So maybe just because we're getting started off, it's really useful that if we make any mistakes before we fully translated the program, it'll tell us at which line and at which space in the program we've made our mistake. Okay, so they're always quite easily spotted as well, because usually whatever program you're using to translate your program, it'll actually highlight your mistake as well. And again, we'll have a look at this in more depth when we're able to practically program when we're back at school. If we have a look at compilers now, so this is the other way of translating high-level program code into binary or into machine code instructions. A compiler translates the whole high-level language program into machine code in one single operation. The original high-level language, okay, so just that program that you've written in plain English, okay, that is actual code, is called the source code, and it's translated into object code or machine code. This object code runs really quickly because it doesn't need to be translated every single time the program is run. So if I've created a program using a high-level language and then I use a compiler to translate that program, that's it, completely translated. So every time I try and launch that program that I've just written, it'll appear really quick and it'll run very quickly because it's been compiled and translated in one single go. The object code becomes an executable file and it can no longer be edited. Okay, so it's an advantage if it's a program that you've written maybe to be sold, because the users who are actually using the program that you've written can't see your source code, so then they can't steal or edit the code. Okay, so that's what we call an executable file. So if I write a program in Visual Basic and then translate it using a compiler, nobody else can see the source code once that program has been translated into an executable file. Okay, so a lot of our software programs that we use on a daily basis will have been translated using a compiler, because if you think of things like Microsoft Word or any other program that we use, you can't see the source code. You just assume that because that's a software program, you double click it, you're double clicking the executable file, it then opens the program and allows you to use it. Okay, so that's when we know that it's been translated using a compiler. So here are some comparisons between interpreted programs and compiled programs. You'll see here at the bottom I've said that the advantages are highlighted in green. Okay, so if we have a look, interpreted programs are translated or interpreted one line at a time every time the program is run, whereas compiled programs, it's the whole program that's translated in one operation. Okay, and that's why it's an advantage, because it's quicker and it's a lot more user friendly if you use a compiled program to translate your if you use a compiler to translate your programs, okay, because it just has to happen in one go. Interpreted programs run really slow because obviously they're being translated every single time, line by line, whereas compiled programs run really fast because they've already been translated in that one single go. Interpreted programs report the position of errors immediately, so that's what I was saying. It'll tell you exactly what line you've maybe spelt a word wrong or written some incorrect code. If you're using an interpreter to translate that program, it'll actually tell you where that error is straight away. Whereas compiled programs report mistakes at the end of compilation. Interpreted programs can't save the translated version, whereas compiled programs, you can save the object code. Compiled code can't be edited then, because we've created that executable file. You can't edit the source code if you've used a compiler to translate your program. And then finally, interpreted programs don't need to leave the editing environment to run. So the editing environment is, as I said, Visual Studio for our example, because we're using Visual Basic. The environment that we write our code in is known as Visual Studio. So when we're using an interpreter to translate the program, we don't actually need to exit that program before we have to run whatever we've written. And obviously then compiler isn't required to run the code, so it requires less memory to execute it as well. So that's everything that you need to know in order to complete task sheet 6. I will put some more information on the notification. I will attach obviously this video to the notification as well, and then I've put all of the theory at the top of the task sheet, just as I have done with every previous one. Okay. If you have any questions or concerns about this piece of work, definitely just either drop me an email or add a comment to this piece of work, and I'll get back to you as soon as possible. Okay, good luck.